Okay, I want to look at the standard we were on before we took all those assessments and before we had the break. So we haven't taken this one, okay? This is going to be the one everybody takes on the final, I believe, okay? No matter, and then if you don't have other standards you need to take to get them locked, then you will want to definitely look at doing those in the next few weeks. Okay, so we're solving inequalities. So some number x minus 9 has to be greater than or equal to negative 5. So I need to find out all the numbers for x that make that happen. So I put a 1 in front of the x and box it. Now that's your only x. It's positive, so the sign's going to go the same way. So plus 9, plus 9. So when I have 1x, that's pretty much my answer. And then negative 5 plus 9 is 4. Okay, so the critical number is 4. So circle, fill it in, and it's anything greater. Okay, this problem needs to be reordered because when I'm solving inequalities, I need the expression that contains a variable first in the sentence. So 5 plus x, negative 2. So the greater than now flips to less than. And then I cross that out and just ignore it. Okay, there's only one sign, so when I see only one greater than or less than sign, I'm just looking for one number. So I box up the 1x. Okay, so outside we got a 5, so I'm going to minus 5. And by the way, that 1x is positive, so there's no need to that the sign's going to stay less than. So that means I have x, negative 2 minus 5, negative 7. So my critical number is negative 7, and it's anything that's less than that. Okay, my next problem. X is on the correct side, so when I box it, the negative 3 is included with that, and this time my x term is negative, so the sign needs to flip over to greater than or equal to. So all I do is multiply the negative 3 to the 4, so I'm just going to times negative 3. Okay, so it's going to give me x, and then 4 times negative 3 is negative 12. So negative 12 is my critical number. It can be equal to it, so it's greater than, so I go this way. Okay, my next problem, again, there's just one critical number. Well, this time I've got x's on each side. So what I need to do is get rid of that x. So minus 2x, minus 2x. So negative 3 minus 2 is negative 5x, and then plus 1. Okay, over here you got negative 14. Okay, now I know that my x is negative, so the sign needs to flip over. So I'm minusing 1, minusing 1. So I have negative 5 times x equals negative 15, and then I divide both sides by the negative 5. Okay, so that's going to be x, and that's going to be 3. There's your critical number. You can be greater than, you can also be equal to. Okay, then a couple on the other side. Okay, this time that's a negative 3x. Now I have two inequalities. So since I have two inequalities, there's going to be two critical numbers. Okay, and what I'm trying to find is 4 plus negative 3 times x. That expression has to be negative 2 is less than that, and 13. So I have to find the two numbers pretty much that x is between, like the boundary. Okay, so my x is negative, so both those signs need to turn around. Okay, now outside the box we got 4, so I'm going to minus 4, and minus 4 there. We got to minus it on both outsides. Okay, so negative 2 minus 4 is negative 6, and over here you got negative 3x. And over here you got 9. Okay, so now it's dividing by negative 3. And those signs turn around because I'm dividing by negative, so that's going to be 2. That's going to be x. That's going to be negative 3. So those are your boundaries. So I can get positive 2 and negative 3. Okay, so fill them both in. And that way. Okay, now it's back to just one sign. So there's one critical number I would be looking for, so I think. So I need to use some rainbows here. So it's going to be 4x plus 2. And over here is 4x plus negative 3. Well, I have x's on each side, but the problem is they're the exact same. They're identical, so I can cancel them. Now, 2 is bigger than negative 3, so does the sign open up towards 2? No, it doesn't, so that's a no solution, and we can't graph no solutions and all solutions. Okay, now graphing inequalities. So I have to graph y is less than x plus 4. What the graph does is it finds all x, y combinations that could make that true. Okay, I have to represent that. That's the purpose of a graph. Okay, so first off, here's my sign. Is the y over here by itself? And is the x over here? Yep, so it's in slope-intercept form. There's no fractions, so we can just go 0, 1, 2. Okay? So if I plug 0 in, 0 plus 4 is 4. If I plug 1 in, 1 plus 4 is 5. And if I plug 2 in, 2 plus 4 is 6. You could also use your slope-intercept, so m would be 1 and b would be 4. So slope is 1 over 1, and the y-intercept is going to be 4. Okay, so 0, 4, 1, 2, 3, 4. 1, 5, so write 1 up, 1, 2, 3, 4, 5. And then 2, 6, write 2, 1, 2, 3, 4, 5, 6. Okay, and then that accomplishes the same thing if you do it that way. You're at 4, then up 1 over 1, up 1 over 1. Okay, now we don't have an equals bar, so it's going to be just a dash line. Okay, now I got to decide which side of the line has all the x, y points that are true, which side has all of them that are false. So the best point to test is 0 and 0. Okay, so I replace both those with 0. And then I'm just going to put 0 plus 4, 1 times 0 is 0. Here's where the math's happening, and that's 4. 4 is bigger, and it opens up towards 4. That's true. So that's true. And go to the other side of the dotted line, that's false. Any xy point over here is true. Any xy point over here is false. Okay, next one. Here's my inequality. The y and x are together, so that makes it in standard form, so I need to graph it differently. I'm going to put 0 for x, 0 for y. And that would be negative 5. So 4x plus negative 5y, just put a regular equal sign. Okay, so x is 0, get rid of it, and then y is 0, get rid of that. Okay, so we're going to divide. So that's going to be y equals 4. So that's 4. Divide both sides by 4. That's going to be x equals negative 5. Okay, so 0, 4 means I just go up 4, and then I go left 5, and then stay at 0. Those are each point. So 0, 4, 1, 2, 3, 4. Negative 5, 0, 1, 2, 3, 4, 5. Okay, now we do have the equals bar, so it's just a solid line, regular line. And now I test my point out for the greater than portion of the representation. Okay, so I'm going to put 4 times 0 plus negative 5 times 0. It's greater than or equal to negative 20. Okay, so 4 times 0 and 5 times 0, that all makes 0. Now what's bigger, 0 or negative 20? 0 is bigger, okay? That's true. Okay, so we have true and false. Okay, next problem. Where's the x? I don't have it, okay? So what I do under the y, because it was y, I just put a big negative 6. Y is always negative 6, and then x can be whatever, so 0, 1, 2. Okay, so again, every time it's negative 6, so 0, negative 6. 1, 2, 3, 4, 5, 6. 1, negative 6, so right 1, 1, 2, 3, 4, 5, 6. 2, negative 6, so right 2, down 6. Okay, it's equal to, so it can be a solid line. Okay, so here's my point, and that's 0, 0. Okay, so all I do is put 0 in for y since the x doesn't exist. Okay, well 0's bigger, opens up towards the right number, that's true. So any point on this side, then now look at the line, go to the other side and put false. Okay, now this is an easy story problem. As a student council treasurer, you prepare the budget for your class rafting trip. Each large raft costs $100, each small raft costs $40. You have $1,600 to spend. Graph a representation of the combinations of small and large rafts, so it's small and large. We'll have the x-axis be small and the y-axis be large, and it doesn't really matter which one's which. And you got to know where 0's at. 0's here and here. 0, 0. Okay, so let's not confuse ourselves by writing a ridiculous equation. Let's just pretend we have $1,600, okay? Let's say all I want to do is rent small rafts. So I have $1,600, and the small rafts are $40 each. So I'm trying to figure out how many $40 go into $1,600, which is just division. That's 40. Okay, so I'm going to number the 40s by 5. So 5, 10, 15, 20, 25, 30, 35, 40, right there. Okay, now let's switch gears and say, what if all we got's large rafts? Well, I have $1,600 to spend, and those cost $100 each. So I'm trying to figure out how many of those I could buy. It's just street math, basically. Something everybody needs to know. Okay, so 16. So I can go by 2s on that one. So 2, 4, 6, 8, 10, 12, 14, 16. You can have one go by 5s and one go by 2s. I'm going to just put a 5 there to tell me I'm going by 5s and a 2 here for 2s. Okay, then connect them. Now here's the deal. There were problems before where I was shading outside the little triangle, but not on this one. Because I'm not making the money, I'm spending it, and that's how much I have. So basically I can't go outside the triangle on this one. Okay. So we need to color in the inside. All those are your points, the highlighted points. When I color it in, I'm not crossing it out, I'm highlighting it. Okay. Okay, whoops, that got cut off. Next one, your friend is starting a small business baking and decorating cakes. He wants to, there's that word profit, okay, of at least $250 in a month. The expenses are $155. Your friend's going to sell the cakes for $10 each. How many cakes will your friend have to sell to meet his profit goal? Okay, so we need to make a profit chart. There's money made, and there's money that we spent. So what's my profit goal? I want to make $250. So I don't use that on the table because that's my profit. Expenses $155. Okay, well that means we spent that. And then $10 each. So when I'm selling it, that's money made. But I don't know how many times I made the $10, okay? Because it's every cake. I don't know how many cakes, so it's 10x. This is an easy one. It's just 10x minus 155 equals 250. So I just plus 155 plus 155. So 10x equals 405. Divide by 10, you get 40.5. Now you can't sell 40.5 cakes. It's got to be 41 then to meet your profit. Again, it's money made, you jot that down, and then minus money that we spent. And I reason that as an X because I don't know how many times I made $10. I spent the 155 just once. That's why I didn't put a variable on that. Okay, absolute value. Don't worry about this one down. Well, I need to get a new one of those. Okay, obviously I'm not going to redo the whole thing. And now let's talk about, where's it at? Okay, now let's talk absolute value. That's what those brackets mean. Let's get this here so you can see what I'm doing. Okay, the absolute value of -4 plus the absolute value of 16. Each absolute value contains just one value, so we can get rid of the brackets. The absolute value of -4 is 4. The absolute value of 16 is 16. 4 plus 16 is 20. Okay, now, I'm not ready to get rid of the brackets. The reason why is because I need to get one number. 2 minus 16 is -14. 3 plus 6 is 9. The absolute value of -14 is 14. The absolute value of 9 is 9. 14 plus 9 is 23. Easy problems. 3 minus 10 is -7. -2 plus 6 is 4. So the absolute value of -7 is 7. The absolute value of 4 is 4. And 7 minus 4 equals 3. Come on, that's easy. Now we're solving equations. Each one of these need charts because they always have two answers, at least I think. Okay, first off, I know what the absolute value equals. It's equal to 4. So 4 and -4. And then what's inside is just x. Okay, I pretty much have my two answers. Okay, next one. The absolute value is equal to 10, so it could be at 10 or -10, because you're thinking number line. How many, what places on a number line can I be 10 from 0? 10 and -10. So you got 3x minus 2, 3x minus 2. Plus 2, 3x. 10 plus 2 is 12. Divide by 3. That's x equals 4. Okay, -10 plus 2 is -8, and then we divide each side of the equation by 3. Okay, -8 divided by 3. You can put, I'm just going to actually leave it in fraction form when it ends up as a repeating decimal. Okay, a little interesting one here. Here's a problem. We don't know what the absolute, it's 5 times the absolute value of x plus 2 minus 3 equals 12. Okay, here's a problem. You don't know what your absolute value actually equals because it's being multiplied by 5 and it has a 3 that's being subtracted from it. So what I need to do is I need to first deal with my subtraction of 3. Now don't be lazy. You got to show your work. Plus 3, 15. And over here you got 5 times the absolute value of x plus 2. Now I need to undo the multiplication of 5. So I divide by 5 and divide that by 5, and that's 3. Okay, so now I know my absolute value is 3. That could be a 3 or a -3. And inside you got x plus 2. Okay, so minus 2, x equals 1. Minus 2, -5. Okay. All right, now, again, I don't know what my absolute value equals because I have a -3 multiplying the absolute value and a 6 being subtracted. So first I undo the subtraction of 6 by adding it to both sides. -6, -3 times the absolute value of x minus 4. Then I undo the multiplication by dividing. So that's equals 2. So the absolute value of x minus 4 equals 2. So it's equal to 2 and -2. And then you got x minus 4. Okay, so plus 4, 1x equals 6. So there's your first answer. -2 plus 4 equals 2.